Hello, this is Mr. Collier, and today we're using sign diagrams to show where a function is increasing or decreasing. So if we look at this example, we look at this graph here. We see we have two important points are labeled. Those are points at which the derivative is 0. So basically, the slope of the tangent line is 0 at these points. Okay, that means at these points the function is neither increasing or decreasing, so these 2 points are also called stationary points. Okay, stationary because they're not increasing or decreasing. The function is not increasing or decreasing at these stationary points. So at these 2 points we have stationary points, and then we look at the regions between or after or before these points, and we can figure out where the function is increasing or decreasing. So here, before we get to -1, we have the function is increasing. Then from -1 to 2, we have the function is decreasing, and from positive 2 on, the function is increasing. Okay, so the way we can do that with a sign diagram is we can just look at and just focus on these x values here. This is -1, this is 2, these are our stationary points. So in between these values we have here that the function is increasing in this region, and here from -1 to 2 we have the function is decreasing, and from 2 onwards we have the function is increasing. So this sign diagram shows where the function is increasing and where the function is decreasing. Okay, you could also write that like in intervals notation. So if you check out the intervals, the function is increasing when x is less than -1 and when x is greater than 2. The function is decreasing when x is between 2 and -1. So next example, we have this function. We're going to find where the derivative is equal to 0. So in other words, we're looking for the stationary points. So when the derivative is 0, it's not increasing or decreasing, and those are called the stationary points. So I'm going to look at the graph on the graphing calculator. So I'm going to type in the function. I'm going to go to Zoom 6, and here's the function. We can see it looks like there's 2 turning points here. Okay, there's a minimum and there's a maximum. Those are going to be our stationary points. So function looks like this. We have 2 places where the slope of the tangent is equal to 0. Okay, so those are the 2 stationary points. So we could differentiate and solve for the derivative equals 0, but actually it's just asking you for these 2 points, so we don't need to even actually find the derivative here. We can, on our graphing calculator, we can find the maximum and the minimum points here using second function, trace, and so we'll go to 3 for minimum, and we'll get this point right here. So we'll go to the left of that minimum value, then we'll go to the right of that minimum value, guess right at the minimum value, and then we get this. Now when you get this come up on your calculator, this is actually scientific notation, -2.53 times 10 to the power -6, so it's actually very close to 0. Okay, so your calculator's estimating is actually, the actual answer is probably exactly 0. So that point is 0, 5. Okay, so that point is 0, 5. And the next one is this one here. The stationary point is a maximum. So we're going to go to maximum, and we're going to find that point. We're to the left of it. Then we go to the right of it, of the point. Then we go right on that point and press enter. So 2, 9 is that point. Okay, so we have 0, 5 and 2, 9 are the points at which f prime of x equals 0, the stationary points. Okay, so make a sign diagram. I can make a sign diagram maybe even right underneath this graph. Here is the point at which x is 0. Here's the point at which x is 2. And in between there, we're either going to have positive or negative, depending on if it's increasing or decreasing. So here on the graph, you can see it is decreasing. So it's negative. The negative sign means decreasing. Here increasing, and here is decreasing. Okay, so also please note that here the derivative is less than 0, so you might get asked this question on the test or something. F prime of x is greater than 0, the derivative is greater than 0 here in this region. And here we have the derivative is less than 0 because it's decreasing. Okay, so decreasing, increasing, decreasing. Notice that's the sign diagram. State your answer using correct notation. Alright, so we have to find the intervals in which is increasing or decreasing. So increasing when x is when x is, sorry, there's only one place. When x is between 0 and 2, it is increasing. So x is between 0 and 2. Decreasing when x is less than 0 and when x is greater than 0. Okay, next example. So next example, first we're going to find the derivative of this function, and then we're going to solve f prime of x equals 0. So the derivative of this function is, we have to do negative 2/3 times the exponent 3, reduce the power of x by 1, then we're going to have 4x plus 6. So when I do that, these 3's will cancel. I'll get negative 2x squared plus 4x plus 6 is the derivative. Then we're going to solve, so we're going to solve this. Solve that for 0. So I guess we could solve that using polysmalt. Let's do that. Let's use polysmalt to solve that. We could also use the graph. But if I do, okay, apps 3, and go to polyroot finder, next. So I'll just type in these coefficients. So we have negative 2, 4, and 6. I'll press solve, and we get x equals 3 and x equals negative 1. X equals 3, x equals negative 1 are the places where the derivative equals 0. So those are actually equal to the stationary, or the locations of the stationary points, which we'll probably need for the next part of this question. So we've got those stationary points. Identify the intervals in which the function is increasing or decreasing. So let's take a look at the graph first. So go to here, I'm going to type in the function. So we have this function, alright, I'll use the fraction feature. So it's negative 2/3 x cubed plus 2x squared plus 6x plus 3. Okay, so here is the function. I'll do zoom 6, zoom standard. Okay, so we got this function. We can't see the top right now, so I can go into Window and increase my y maximum maybe to 20. Let's try that. 20 should work. So then I'll go to Graph. Oh, maybe actually even 30. Okay, so now I can see this minimum and this maximum, the stationary points, right? So the first one's going to be -1 at -1. Second one's going to be at -3, and I can see where everything is increasing and decreasing now. So the graph looks like this, where this is -1 and this is 3. And then we have basically, I'll draw the sine diagram. The question is asking for the intervals. So that's -1, that's 3. We are decreasing here, and then increasing, and then decreasing again. So the intervals at which the function is increasing, it's increasing at or between, when x is between 3 and -1, and it's decreasing when x is less than -1 and when x is greater than 3. Okay, next example. Identify the values of x for which the function, the derivative equals 0. So it's talking about the stationary points. Alright, stationary points where the slope of the tangent equals 0. It's kind of a poorly drawn graph, but if it was smoothly drawn, you have this point, and this point are the stationary points. So identify the values. So the values of x, basically, so it's asking for, so at -9, at -3, and at 5, we have stationary points. Write down intervals for which f prime of x is greater than 0. So that means increasing. Where is the function increasing? And that would be here it's increasing, and over here it's increasing. So when x is between, remember these are our stationary points, -3 and -9 is increasing, and also when x is greater than 5. Okay, and where is the function decreasing? It's decreasing over here, and it's decreasing over here. So it's decreasing when x is less than -9, and when x is between 5 and -3.